on this constraint so that we can get some basic foundation and get some grip on this particular problems, right? Yeah. So let us start with the first problem. And in the distribution operators also, we have some other type of things that we will discuss. Okay, so how to and how and what we are going to discuss, not an issue. Okay, first we will discuss about this problems on this constraints, and let us move forward. And most probably this Saturday we are going to start with the project of test bench development of decoder based RAM, okay, using SystemVerilog. So first we are going to discuss about the SystemVerilog test bench architecture, functional coverage, and code coverage. Then we are going to start with a project on decoder based RAM that we are going to discuss. That is the plan which I'm going to thinking, which I'm thinking. Okay. Yeah. So let me share my screen. Hope my screen is visible, right? For each loop we have discussed in the starting sessions only. Uh, yes or no? Please let me know if you are attending from the first session. I think I have discussed in the first. Yeah, constraints I will discuss. In constraints, how to use your for loop, for each loop I will discuss. But regarding for each loop, already I have discussed it now. What do you mean by for each loop and all? In the arrays concept, in the arrays, when you want to insert any elements, we have three methods: for loop, for each loop, and array aggregate method. Yeah, okay. Now, let us see the first question. So the questions will be from the basic. Okay, first we will start with the basic things. Okay, and we will slowly increase the difficulty of the questions. Okay, so I will be first of all writing down a particular question. You can take 2 minutes of time and you can come up with your solution, not from the GPT, and then we can have the discussions. Okay. So first of all, here my first question is: we need to create a dynamic array. So we need to create a dynamic array, and we need to allocate the size of this dynamic array using constraints. So we need to allocate the size of the dynamic array using constraints. Allocate size of dynamic array using constraint. This is most widely used in in any codes like in GitHub or somewhere. If you observe the size of the dynamic array, they will be normally allocating using the constraints. So we need to allocate the size of this dynamic array using the constraint. Let's say the size of the dynamic array we need to allocate as 10. Okay. So anyone once have it a try. You can take your time, 2 minutes of time, and come up with a solution. We will discuss. Okay. Yeah. We are going to use a keyword which is known as dot size. Okay. So how to write it down? So simple, we are going to have a constraint. We are going to declare a constraint, and let's say the constraint name is size underscore array. This is my constraint name which I'm going to have. And here what I'm going to use is array dot size, which is equal to 10. And here we are not going to use single equal to, here we need to use double equal to. Okay, here constraint is going to check whether this condition is being satisfied or not. That's why we are going to use double equal to, not single equal to. That's it. This is how we are going to allocate the size of the dynamic array, but not using the new operator, but using the constraint. Okay, exactly correct. Okay. Yeah, you can also try it using the EDA playground. After your solution, you can also try it out. Okay. Okay, that's great. That's a great start. Now let's see one more question. So in the same array which we have created, uh, the array which we have created, right? This particular array, we should have only even numbers inside this particular array. This array should have only even numbers. This is a very simple question, I think. Many can do this easily. So the array which we have created, right? This array should have the even numbers. We need to write down a constraint for this. Exactly. Percentage 2 we can use for checking whether we are going to have not even index. Here the question is all the indexes should have uh, the even numbers only. Okay. Others also please try. We are going to write it down. So what do we need? We need to have all the indexes should be of only even values. Okay. So I'm going to have a particular constraint like this constraint. Let's say the constraint name is some C2. Okay. In this particular constraint, I'm going to use a for each loop. So for each of, I'm going to use array of I. Okay. And in this particular array, what is that I need to have? This entire indexes inside my array should have only even values. That means array of I percentage 2 equal to 0. That's it. So what is happening over here? Array of 0, it will check whether it is divisible by 2 or not. If it is divisible, then it is going to store the value. Let's say suppose array of here we are also randomizing it. When we are randomizing the values, here whatever the random value which we are going to store in the index 0, that it will make sure that it is an even value. Okay. And next, whatever the random value which we have generated, that particular value will should be an even value, that is it is going to check and it is going to store it in index value 1. So like this, all the 10 locations will be filled. So this is the code which we are going to write down for storing our even numbers inside all the indexes. Okay. Can you tell me writing even numbers using? Okay. This is what is this operator known as? Division operator or modulus operator? Can you tell me writing even numbers using percentage? Without percentage. Okay. That's anyone wants to answer? How to write down writing down even numbers, but you should not use percentage operator. What we can do? MSB should be exact. MSB or LSB or AFI, if you multiply it by 2, you're going to get. Yes? Yes, LSB should be equal to 0. Is it clear? Okay. So let me implement this and give me 1 minute. Yes. Okay. Now, let's see one more question over here. So let's say if the question over here is in this particular array, even indexes should have my odd values. This is the question. So the requirement over here is whatever the even indexes which we are going to have, right? That particular even indexes should have odd values. Now come up with this particular solution. What can we write down over here? The even indexes should have odd values. Exactly. So first of all, we need to check whether the index is even or odd. Okay. So what I'm going to have constraint, let's say even underscore values, let's say it as, and in this thing, what we are going to do is again we are going to use for each loop. So for each of ARR of I, this is my array. What I'm going to make sure that first of all, my index, if it is a even value or not, I'm going to check it out. If it is an even value, then I'm going to store an odd value in it. So what I'm going to write down ARR of I percentage 2 not equal to 0. I'm going to store the odd values inside it. Okay. So this is how we can store the odd values inside my even value. Odd values inside my even indexes. Okay. Yes. Now, let's take one more question over here. Let's say if I want to have unique elements stored inside my array, unique elements in the array. I need to have all the unique elements in the array. Now, how to get it? I need to have all the unique elements in all the indexes. Think about it. Yes, I can use RANC, but RANC, we have seen, right? It might or it might not generate the unique elements. So best using unique keyword is a better option. So how to use it? So constraint, we are going to have, let's say the constraint number is C4, which I'm going to have. And in this constraint, what I can have is simply unique of my array. So this keyword will make sure that this array is going to have only unique values that are being generated. Okay. So this is how I can use my unique keyword. Now, let's say one more question. I need to perform sorting. So I need to sort my array values in ascending order. Sorting of array values in ascending order. Now try this one. How to sort your array values in your ascending order. I can use a keyword which is known as sort for sorting the array values. Okay. Now, okay. Or else I can also use the indexing. Exactly. I can use either indexing or else I can also use my keyword which is known as sort. So how to use this indexing? Let us see the indexing, using the indexing, how to use it. So I'm going to use a for each loop. Inside my constraint, I'm going to write down for each of ARR of I, which I'm going to have. Here, what we are going to do, first of all, we need to check whether I is greater than or equal to 0 or not. If it is greater than 0, then we are going to write down the condition array of I, that is present index value, is greater than the previous index value. Okay. So that is what we are going to do. Is it clear? Yes. So that is nothing but my sorting, which I'm going to do. Now, let's say if I want to get the sum of all the array elements. Let's say if I want to get the sum of all the elements, all the array elements, sum of all array elements. This is not a constraint question, but let's have it. Exactly. So I can use a direct keyword which is known as array.sum, which will basically return you the sum of all the array elements. Okay. Now, the final question, let's say, here the question is no to array adjacent elements should be equal. Think about it and answer. So the adjacent elements of your array should not be equal. For that, we need to write down the constraint. Exactly. Correct. So what we can write down over here, array of I should not be equal to array of I minus 1. So it will make sure that your two adjacent array elements are not equal to each other. Okay. Yes. So these are some of the questions which are related to constraints. I'm basically categorizing them. So on the dynamic arrays, we uh, uh, have collected some questions. And next, in our next session, we will discuss some questions related to queues on this constraints. And after that, we will try to have the discussion on associative arrays and other categories of questions like pattern printing. We will have some pattern generation or some like that type of questions. I've categorized them. Okay, so category wise, we are going to discuss. And as I've said previously, that by Saturday we will be discussing about the test bench development and test bench architecture, functional coverage, and code coverage, hopefully. And from Saturday, we are going to start with the project which is known as decoder based RAM verification that we are going to start. Okay. Yes, so that is a plan which I'm thinking about. Okay. Yes, so that's all about this particular session. If you have any doubts or any other queries you wanted to discuss, you can stay and discuss with me, or else you can leave the session. Okay. Thank you. Good night.